So this video is for Integrated 3, Chapter 8, D-Day number 2. So on number 1, we're going to be sketching this graph, okay? And what I first want to do is find my zeros here. So when I'm finding my zeros, I have 0, -4, 1, which is a double, and -2, which is a triple. So in terms of degree, 1, 2, that's going to become a 4, 7. So this is going to be a negative degree 7. Let me write that over here. Okay, so that's going to be a negative degree 7. And if you think about odd degrees, think about lines. So it's like a negative line. It's like a decreasing line, which means that the end behavior is up, down. That's going to be our end behavior. So now let me get a graph. I'm not going to scale my x-axis. I'm only going to, my y-axis. I'm just going to scale my x-axis. So let's see, 1, 2, 3, 4, 1, 2, 3, 4. So -4, +4. And I know that I have a 0 at 0. I have a 0 at -4. I have a 0 at 1, which is a double, and at -2, which is a triple. So this one here, this one here is my triple. And this one here is going to be my double. And because this is a negative odd degree, it's going to be starting above and going down. So let me draw my graph. So I am going to be starting above, going through. This one's a triple, so it's going to look like almost like half of an open down and half of an open up parabola. Okay, it's a cubic look right there. It's going to come and go through. And then when it comes up to this one, which is a double, it's going to come up and bounce back like a parabola. On number 2, they're asking us to write the exact. So that means I want to be precise. That means they give me a point. The point that they're giving us is this 0, -2. That's the point. Now I'm going to zoom in here and I'm going to focus on my zeros. So I have a 0 here at, and it tells me -3 and it bounces off. So really that would have been an x plus 3 squared. Let me maybe write that a little smaller. So that would be an x plus 3 and it's going to be squared. I have a 0 here at 3. It's going through. So that's going to be an x minus 3, and that's just going to be a single. And I have one here at 8. So that's going to be an x minus 8. And again, that's just going to be a single. And let me just kind of get rid of that so we can kind of see the flow. So for this, what I'm going to do is write out my factors and my a, and then substitute that point into it. So let's see. So I will have y equal, let me go y not like an x, y equal a times x plus 3 squared times x minus 3 times x minus 8. Just kind of a side note, this looks like it might, well, this is going to be a degree 4 and it's going down, so it should be negative, but I'm not going to put a negative here in front. My a will become negative when I put this point in and I work it out. So I'm going to put in 0, -2. That's the point that they gave us. So I'm putting -2 in for my y and 0 for my x. And then we're going to work this out. And I get -2 is equal to a times 9 times -3 times -8. Okay, so let's see. 9 times -3 times -8. I end up with 216. So I'm going to have a -2 is equal to a positive 216a. So I get -2 over 216 equal a. And when I do that, I can simplify that to a -1 over 108. So it's going to be y equal -1 over 108, x plus 3 squared, x minus 3, x minus 8. Leave it as a fraction. Don't change it to a decimal because that's going to be an approximation. And that's your answer. On number 3. Okay, so we're going to write this in standard form. So standard form means I'm going to multiply this out. So I'm going to have x plus, get a little thicker here. I'm going to have x plus 1 because I have a -1 as a root, x minus 3 because of my positive 3, and then for my 7, that was an x minus 7. So I'm going to be multiplying 2 of these together, and then I'm going to multiply it with the third one. So if I multiply those together, I'm really thinking of this as a diamond. Okay, I'm going to draw it, but I usually just think it with a 1 and a -3. So I basically want to take these two numbers and add them, which is a -2, and multiply them, which is a -3. So I'm going to get x squared minus 2x because that's what I got when I added, minus 3 because that's what I got when I multiplied, times an x minus 7. So now I'm going to do that math. And I have x squared minus 2x minus 3 and an x minus 7. And so I get x to the third minus 2x squared minus 3x, negative 7x squared, a 14x, and a 21. So that gets me an x cubed minus 9x squared plus 11x plus 21. On number 4, we're going to divide. And so when I'm doing this, since it's an x plus 1, I'm going to use synthetic division. And I'm going to put a -1 because that's what would be making x plus 1 0. I'm going to have 1, 4, -7, -10, making sure it's in descending order, making sure I'm not missing a term. Bring down the first number, which is a 1. And now I'm going to multiply 1 times -1, which is -1, and I add it, I get 3. 3 times -1, which is -3. I add it, I get -10. -10 times -1 is a positive 10, and I got a 0. So this actually was a factor. So my answer is going to be x squared plus 3x minus 10. I don't have to add my remainder over x plus 1 because I have no remainder. On number 5, we want to find the roots of this. This is a quadratic in nature one because it is a trinomial with an x squared and then an x to the 4th. And if I squared x squared, I get x to the 4th. So this is just like a quadratic. And again, I call it quadratic in nature. So I really want to think what multiplies to 12 and adds to 7. And that's going to be a -4 and a -3. So I am going to get x squared, because that's what my middle term is, minus my 4, and x squared minus 3 equals 0. Now, again, I can think of this two ways. I can factor this, which is a difference of two squares, and get an x plus 2, x minus 2. And I can factor this, which is going to be a difference of two squares, but I'm going to get a square root. So that would be an x plus root 3 and an x minus root 3 equals 0. So you see my answers, I'm going to have a negative 2, positive 2, negative root 3, positive root 3. Those are my 4 answers for my degree 4 polynomial. Now again, some of us might have trouble doing that with this because maybe we don't feel comfortable if it's not a perfect square. So what we could have done is taken x squared minus 4, set it equal to 0, and the x squared minus 3 and set that equal to 0. I get x squared equal 4. I take the square root. I get a positive and negative 2. This one, I add the 3. I take the square root. I get a positive and negative root 3. So you see, either way, I get the 4 answers. On number 6. So for this, I'm going to do my P over Q's. This is my Q, which is 1. Love it. It's going to be integers because my denominator will only have 1 on it. Unfortunately, my P is a 48. It's a negative 48, but it's a 48. So I have a lot of choices for my P. So when we do P over Q, again, I would put all my factors of P over all my factors of Q. But since my factors of Q are just 1, I get just integers. I'm not going to get fractions. So now I'm going to get plus or minus 1. So I'm going to sit here and think about things that go into 48. 1 goes into 48, 48 times. 2 goes into 48, 24 times. 3 goes into 48, 16 times. 4 goes into 48, 12 times. 5 does not. 6 goes into it 8 times. 7 does not. So now I've got 8. So now I'm matching up. So 8, 4 and 12. 3 and 16, 2 and 24, and then 1 and 48. So that's a lot of ones to choose from, but at least they're not fractions. So I'm going to do my synthetic division, and I want to be careful because I think I'm missing a term. I'm also going to be starting with a degree 4, which means I have to take it to a degree 3 and then down again to a degree 2. So I have 1. I don't have an x cubed, so I'm going to put 0 for my x cubed. 1 for my x squared, negative 14 for my x, and a negative 48. Okay, so let's say I start with a 1. Let's just see what happens. Okay, bring down my 1. 1 times 1 is 1. I add it, I get 1. 1 times 1 is 1. I add it, I get 2. 2 times 1 is 2. I add it, I get a negative 12. Negative 12 times 1 is a negative 12. I add it, I get a negative 60. Okay, getting a little further. So I started at my 0 being at 48 below the x-axis, but I'm still below the x-axis. I'm still moving that direction. Let's try 2. 2 times 1 is 2. I add it, I get 2. 2 times 2 is 4. I add it, I get 5. 5 times 2 is 10. I add it, I get a negative 4. Negative 4 times 2 is a negative 8. I add it, I get a negative 56. Okay, moving the right direction. 3. 1 times 3 is 3. I add it, I get 3. 3 times 3 is 9. I add it, I get a 10. 10 times 3 is 30. I add it, I end up with a 16. 16 times 3 is 48. I add it, I get a 0. So sometimes it's really tempting, especially when I saw that 1, I'm at negative 60, to maybe jump ahead a couple. But sometimes you might jump ahead too much and miss a 0. So I got my 0 at my 3 here. Okay, so this is going to be one of my zeros. Okay, that is x equal 3. So now I'm going to take this 1, 3, 10, 16, and do another synthetic division with this degree 3. Now, notice they're all positive, so I'm not going to do any of my positives whatsoever. I'm going to focus on my negatives. Okay, and right here, focus that I'm at a 16 here, just kind of keeping that in mind. Okay, so let's say I do -1, bring it down. 1 times -1 is a -1, I add it, I get 2. 2 times -1 is a -2, I add it, I get 8. 8 times -1 is a -8, I add it, I get 8. So still going in the right direction. Okay, I'm going to try -2. Bring down my 1. 1 times -2, I add it to 3, I get a 1. 1 times -2, I add it to 10, I get an 8. 8 times -2 is a -16, I add it, I get a 0. So I got my second 0 here. I have at x equal -2. So now I'm going to take this degree 2, x squared plus x plus 8 equals 0 and solve it. Now, unfortunately, this is not one that's going to be factorable. So I'm going to have to use quadratic formula. So I'm going to have x is equal to -b, which is -1, plus or minus my square root of b squared, which is going to be 1 squared, minus 4 times my a, which is 1, and my c, which is 8, all over 2 times my a, which is 1. So I'm going to get x is equal to -1 plus or minus, and I think I'm going to get an imaginary answer here. This is going to be a 1. This is going to be a -32. So I'm going to get the square root of a -31 over 2. So that's going to be -1 plus or minus I root 31 over 2. And those are going to be my other two answers. So I'm going to have x equal -1 plus or minus I root 31 all over 2. And those are my two answers. They're conjugates, complex conjugates. And then I have my 3 and my -2. On number 7. On number 7, this is nice also because my P is my Q is going to be a 1. So they're going to be all integers. My P is 9. So when I do my P over Q's, I'm going to get all integers plus or minus all factors of 9, basically 1, 3, and 9. Now, when I see this, these are all positive, so I don't have to do my negatives. I mean, my positives. I'm going to only do my negatives. So I'm only going to do -1, -3, -9, because when I have my synthetic division here with a 1 and a 6 and a 10 and a 6 and a 9, and if I was trying 1 or 3 or 9, I'm going to keep on getting bigger and bigger. Nothing's going to cancel out. So I need a negative. So I'm going to do -1. 1 times -1 is -1. I add it, I get a 5. 5 times -1 is a -5. I add it, I get a 5. 5 times -1 is a -5. I add it, I get a 1. 1 times -1, I add and I get an 8. Okay, so let's try -3. Bring down my 1. 1 times -3 is -3. I add it to 6, I get a 3. 3 times -3 is a -9. I add it, I get a 1. 1 times -3 is a -3. I add it to 6, I get a 3. 3 times -3 is a -9. I add it to 9 and I get a 0. So right now I have x is equal to -3 because of this. So I'm going to take that, which is now going to be a degree 3. I'm going to do 1, 3, 1, 3. Let me just space this so it doesn't look like a 13. And then I'm going to try some more numbers. So let's see, I'm thinking I know -1 did not work. I know the positives are not going to work. I'm going to try -3, just leaning towards that. If that doesn't work, I'll try my -9. Bring down my 1. 1 times -3 is -3. I add it to 3, I get 0. 0 times -3 is 0. I add it to 1, I get 1. 1 times -3 is -3. I add it to 3, I get 0. So I had x equals -3, so I have it as a double. And now I'm going to take this x squared plus 1 and solve that. So I'm going to get x squared equals -1, which is going to be x equal positive and negative, and the square root of a -1 is I. So I have x equal plus or minus I. So you see that I have -3 as a double, and then I have the conjugates plus or minus I. On number 8, determine the degree and behavior zeros and how the graph crosses the x-axis at each x-intercept. So the degree 2 plus 3 plus 1, this is degree 6, and it's a positive degree 6, so it's like a parabola, which means it is opening up and up. My zeros, I have x equals 0, which is a double. So that means it bounces off. I have x equal -2, which is a triple. And so it's going to be curved like that, where it goes through, but it doesn't go through like a straight line. And I have x equal, so maybe one way to describe this triple is to say that we have an inflection point. So it goes through well, I'll just say it has an inflection point at x equal -2. Okay. And then my x equal -1 is a single root. And so this one just goes through. Okay. The second one goes through, but it goes through with this type of a shape with an inflection point on the x-axis at -2. Okay, number 9. Okay, so this one, again, when you have something in this form where you have 2 logs, you're going to rewrite it as a single log. So it's going to be log base 3 of, and I'm going to multiply the x and the x plus 3. So I get x squared plus 3x. Now, this is slightly different than the one from the last video because we have a log on the other side. So when you have a log base 3 equal a log base 3, what has to happen is this has to equal this. So I am going to basically work out x squared plus 3x equals 18. So x squared plus 3x minus 18 equals 0. So that's going to be an x plus 6, x minus 3 equals 0. So I get -6 and 3. But remember, you can never take the log of a 0 or a negative. So here, when I put this in, that's going to make it negative. It's actually going to make it negative here also. Now, when I put in the 3, here and here, those are going to be positive, so that's okay. So my only answer is going to be x equal 3. The other one is not going to work. Okay, on 10, we're expanding this. So first thing I'm going to do is I'm just going to kind of rewrite this with no radical. So my 2 is going to be raised to the 1/5 because it's a 5th root. My b is going to be raised to the 4/5. and then I have x to the third, or 3x to the third. So I'm going to have 1, 2, 3, 4 different logs here. So I'm going to rewrite this as, and when I take the log of something with the power moves in front. So when I am dealing with this, I am going to have a 1/5 log of 2 plus, and then when I'm dealing with this one, I'm going to have a 4/5 log of b. And then when I'm dealing with this 3, I'm going to have minus log of 3. And then when I'm dealing with this x cubed, I'm going to have minus 3, because of the power that moves in front, log of x. And that's my answer. On 11, we're going to use synthetic division to show that root 6 is a 0. So I'm going to put in root 6 in my synthetic division with a 1, a 2, a -6, and a -12. Okay, I bring down my 1. 1 times root 6 is root 6, and I get 2 plus root 6. Okay, and I'm gonna write it in alternating colors just so that you can see which goes where, because it's going to get a little tight here. Okay, so then when I multiply this together, my 2 times root 6 is a 2 root 6, and root 6 times root 6 is a 6. So I'm going to get a, here, and I'm just going to alternate it here too. Okay, so I'm going to get a 2 root 6 plus 6. Again, 2 times root 6 is 2 root 6. Root 6 times root 6 is a 6. When I add this, those are going to cancel out. And I'm just going to be getting a 2 root 6. And when I take 2 root 6 times root 6, my root 6 times my root 6 is a 6, times the 2, I get a 12. I got a 0. But you need to show the work. On 12, okay, inverse. This is when I'm going to switch my x and y. So I'm going to write x equal the square root of 2y plus 5 minus 7. And I want to get it to be y equal. So the first thing I'm going to do is I'm going to add 7. Then I need to undo the square roots. I'm going to square both sides. I'm going to minus 5. And I'm going to divide by 2. So I'm going to get x plus 7 squared. I can write 2 ways. Minus 5 all over 2 is equal to y. Or I can have it as a 1/2, trying to risk, a 1/2 times x plus 7 squared minus 5/2 equals y. Both of these are the same. Okay, so we have this equation, which is an exponential equation with a asymptote at y equal k. And we have these points it passes through. Now, here's the key here. It has an asymptote at 100. So I know this is going to be a y equal a b to the power x plus 100. And then what I'm going to do is I'm going to put both points into this equation for my x and y. So when I'm doing my 1, 120, I'm going to have y equal, not y equal, sorry, my y is 120. I'm going to have 120 is equal to a times b to the 1 plus 100. I'm going to clean that up and a minus 100 from both sides, so I get 20 is equal to basically ab. I'll deal with this in a second. Okay, so let's do it for the other point, which is 2, 168. Okay, so I'm going to have 168 is equal to a times b to the second plus 100. I'm going to minus 100. and I get this. Now, I am going to substitute one equation into the other. I want to get one of them to be either A or B equal. I think it'd be easier to get it to be A equal, just because I'd rather plug it into just A's as opposed to like a B squared. So I'm going to get 20 over B is equal to A. And I am going to take this 20 over B and put it here for A. So I have 68. 68 is equal to my A, which is 20 over B times B squared. Now, the nice thing is this B is going to cancel with one of those. And so I basically get 68 is equal to 20B. So my B is going to be 68 over 20. And 68 divided by 20 is 3.4. Okay, so my B is going to be a 3.4. Now to find my A, I can put that 3.4 in here. And when I do that math, I'm going to have 20 over 3.4 equals A. So 20 divided by 3.4 equals about a 5.88. So I get about a 5.88 is equal to A. Now, if I want to keep this exact, I can hit my math button. And that means my A, let me just put it here, would be 100 over 17. And my B, if I wanted it to be kind of a cleaned up fraction, that would be a 17 over 5. So when I write this equation, okay, and you're not going to see one like this on the test. I know we haven't practiced as a class, any of us in Integrated 3, this problem as much. Y is equal to my A, which I'm going to write as the 100 over 17, times my B, which is the 17 over 5, raised to the power x plus 100. And that is our equation. On 14, I am going to factor a 4 out of both of these and get 4x to the 12th minus y to the 2nd. Now, 4x to the 12th, y to the 2nd actually is a difference of 2 squares. So when I am doing this, the square root of 4x to the 12th is going to be 2x to the 6th. 2x to the 6th. And the square root of y squared is a y and then a negative y. And that is my answers. On 15, this one is going to be a difference of 2 cubes. So when I'm looking at the cube root of this, that's going to be a 3. And when I want the cube root of x to the 6, I divide x to the power of x to the 6, the power by 3, which is a square. Minus, for the 8, it's going to be a 2. And then for my y, again, I'm going to write this a little smaller. Okay. So this is going to be a 3x to the 2nd minus. And then when I'm dealing with my 8, y to the 9th, that's going to be a 2, y to the 3rd, because 3 goes into 9 3 times. So now I am going to focus on this 3x squared, and I'm going to square it, which is a 9x to the 4th. Change the sign. Multiply these together, which is going to be a 6 x to the second, y to the third, square my 2y cubed, which is going to be a 4y to the sixth. And that's our answer. On the last one, number 16, I'm going to do long division. I'm going to take a 2x plus 1 and divide it into 2x to the third, 9x squared plus 14x plus 5, focusing on the 2x and the 2x cubed. So 2x times x squared, so I'm putting it over the 9x squared, is going to be 2x to the third. So I'm going to multiply it with both of these terms. So I'm going to get 2x to the third plus x squared. And then I am going to minus, so that becomes negative. And then I combine and I get an 8x squared, bring down my plus 14x. And then I ask myself 2x times what gets me 8x squared? And that's going to be a positive 4x. So I'm going to get an 8x squared plus 4x. I'm going to minus, so I make both of these negative. When I add, I get a 10x, bring down my plus 5. And then I'm focused on the 10x. So 2x times what gets me 10x? Well, that's going to be a plus 5. So I get 10x plus 5. I'm going to subtract, and I end up with 0. So my answer is going to be x squared plus 4x plus 5. That is my answer. And that's the end of this video.